Do we want to talk about RF design?
Sure.
So I would say the number one design guide on our website is our RF design guide.
Okay.
So I think it's like just looking at what we see from our website activity, RF is becoming more and more of a hot topic. So, okay, a question I have here about RF is when designing a PCB with an onboard or external antenna, what strategies do you follow to avoid coupling between the antenna and the heatsink?
Probably the best answer I can give to that is one way or the other, you have to keep the antenna completely away from the heatsink. There's just no two ways about it. There's no secondary way to handle that I know
Okay.
of. Antennas on circuit boards are usually not dipoles, they're usually monopoles.
Right.
And they generally reference the ground plane right at the edge. So you'll clear out an area at the edge of a board to build the antenna on. There'll be nothing under that all the way through the board. And then right next to it will be the ground plane that the antenna references.
Like coplanar.
Exactly.
Yeah.
It is coplanar. And if you're going to put a heat sink on that, it needs to be completely on the other end of the board. You can't put something like that in a metal package.
True.
Because the metal package, of course, would destroy the performance of the antenna. People who use metal packages sometimes will even put a plastic end cap on the metal package so they can have the antenna in the area where the plastic is. But in reality, even the plastic attenuates the fields to and from the antenna. So there's nothing you can do to stop some attenuation. The circuit board will create some attenuation.
Right.
And for that reason, sometimes people put the antenna outside the system, with a little coaxial attachment. So the antenna.
And launch.
Yeah, so
And launch.
exactly. So it's completely independent. There's no absolute one answer to that question. But you must keep the antenna away from anything that can attenuate it.
But-
and that's metal, plastics, whatever.
Yeah. See, metal is a big,
Oh,
let's say, absorber of energy, electromagnetic energy.
or reflector, one of
Or
the two,
reflector,
depending
yeah.
on whether it's
And
magnetic.
therefore, a heat sink is metallic.
Yes,
And a large metallic body comparatively to any other metal on the PCB.
that's correct.
And therefore, it's going to spoil the performance of the antenna
Yes, it will.
if it is very nearby.
So it's a proximity thing.
Yeah.
You just don't have a choice. And I've seen people make that mistake
I think
and then wonder why it didn't work.
question arises out of that is that the good thermal design
Yes,
is extremely important at the same time,
it is.
because do you really need the heat sink, or can you manage the thermal,
Right,
let us say the heat removal
right.
and the cooling, effectively through thermal vias and all those kind of things, and
And sometimes you can.
sometimes you can.
But if you do need a heat sink,
Right. And-
probably the best way to handle it if you have a metal package
Right.
is to put the part that needs to be heat sunk on the opposite wall as the antenna and use a heat sink that can be attached to the metal
Right.
so you can use a smaller heat sink. So you use the heat sink to pull the heat out of the IC and then into the back wall of the enclosure to get good distribution of the heat.
Wonderful.
That allows you to use a smaller heat sink. We used to do that all the time in telecom.
Right.
And we were able to keep heat sinks completely away from things that were more critical, like I/O and that sort of thing.
No, I think that's a very smart.
Yeah, it wasn't my idea. I wish it had been, but
That's interesting. So yeah, no. Yes, in RF design, an engineer needs to make all these types of choices. But in every design, it's the same choices. But it seems like in RF design, the choices, if made improperly, are even worse.
they're devastating.
They're devastating. Yeah.
Yep, that's true.
The signal integrity implications in RF are far more prominent, and
Yeah.
they can, decrease your performance
That's
quite a
correct.
bit
Yep.
compared to, let us say, less than RF. kind of
Digital has a much broader noise margin,
right.
hence a lot more leeway to have mild noise or do things wrong at times.
Sure.
RF, no room for that at all.
Does the material selection here makes a difference?
Oh, in RF, huge. Sorry, hold on. It makes a huge difference in material selection because some materials are much lossier than others.
Right.
FR4, though it's a wonderful material,
Right.
is a fairly lossy material. And I've had people say, oh, come on, it's the 3, 4, 5 gigahertz, you can't use FR4. Well, you can if your lines are so short.
If your board is very small.
And yeah, and the lines are very short.
Right.
Then the amount of it, it's still gonna be more loss per millimeter. But as long as you have very few millimeters of length, the loss still may be within an acceptable level. But the point is, if you have long RF lines, then you're probably going to have to go to a lower loss material, like a Rogers 4000 or the Arlon or Taconic equivalent of those,
Sure.
or one of the other high-end materials.
Yeah, Panasonic.
You know, Matsushita, Megtron 4 or 6. I mean, there are a number of materials, depending on whether the design is digital or analog.
I think Rogers have come up with a pretty good set of such materials. And
Rogers
so
have.
has Isola also.
Oh yeah, Isola
Tachyon
and
all
Arlon
those,
too.
you know,
Yes,
yeah,
absolutely.
all those
All of those companies
Right.
have done a really good job of coming up with really high end.
low dielectric losses.
You betcha.
Oh.
And tightly controlled dielectric constant, so
Exactly.
that you get good control of impedance, provided you keep line widths and height above the plane reasonable.
So for basically at RF and higher frequencies, the constancy of the dielectric constant versus frequency is also very critical,
Yes.
because that can introduce additional losses and.
Yes, it certainly can.
and,
That is true.
I think the PCB material manufacturers are coming up with pretty good materials nowadays to basically.
They
address,
certainly are. In fact,
these
I did a class yesterday at PCB West
Mm-hmm.
on attenuation in very high-speed circuits.
Right.
And on one of the slides, I had a list of 8 or 10 materials
Right.
that I've used in my life that are common, starting with FR4, then going to 408, then going to Megtron 4 and 6, and all those, down through this long list of stuff, ending up at Tachyon 1000 or 100 or whatever it's called.
Right.